Hello everyone. Welcome to another episode of Let's Discuss a Paper right after reading it. So in each session, we choose a paper we wanted to read, and then we read it in 2 hours, and then we come back to discuss it. So today we have two people, just me and Yota. Yota, can you introduce yourself?
Hi, I'm Yota Kawashima. I'm doing research assistant, research engineer in Japan.
Okay, and then as for me, my name is Qian Chen, and I'm currently a PhD student at Monash University, Australia. The paper we are going to discuss today is by Ray and Rangnath, 2023, titled Flexible Reuse of Cortico-Hippocampal Representations in Encoding and Recall of Naturalistic Events, published on Nature Communication. So today I'll first give a summary to this paper, and then we'll discuss any questions we have. So, the background of this paper is that in everyday life, the kind of events we go through, such as taking the public transport or doing groceries, each time we experience them, they have many common elements, such as how the grocery store looks, or how like the train platforms look, and then what the people look like. And although they differ in detail in our each experience, for example, every time we ride the bus, the people on the bus are going to be a little different, something like that. So the key question is, how does our brain represent these events, which are different in detail yet similar in overall structure? So based on past research, the default mode network represent these events during our experience of them and our recall of them. And here I'll give a definition of what a default mode network is. It is a large-scale brain network that involve temporal, medial prefrontal, and some posterior cortical regions. Although we already know that the default mode network represents the contents of different events, we don't really know how exactly the DMN process and represent the contents of these events. So right now, there are two possibilities. So one possibility is that all the components of DMN together codes every specific event in an unique and integrative manner, which means that taking public transport today will be coded in a unique way compared to taking public transport yesterday, or something like that. And on the other hand, another view is that the subnetworks of default mode network codes a component of the event. In a sense, an event was pulled apart into different elements, the people, the context, the places, and that gets processed by each component of the DMN. So based on the existing research within the DMN, the posterior medial network would process the context information, or the information about place of an event. And then the anterior temporal network process the objects and people of the event. Finally, these context information and objects, people information gets integrated into hippocampus for flexibly recombine and reuse next time you experience or recall a similar event. So far, it is unclear which view is correct in terms of how DMN represent everyday events. So the aim of the current study is to address the way that DMN represents information about events during the experience of the event, and also memory retrieval of them. To answer this question, this study had participants undergo fMRI scan while viewing and recalling videos of everyday events. As for the behavioral task part of video viewing and recalling, they had each participant view 8 videos depicting everyday events. And for these 8 videos, 4 of them depicts a central person, Lisa, in 4 different everyday situations. And these 4 different everyday situations can be subdivided into 2 in which Lisa is in cafes, although there are 2 different cafes. And then the other 2 are Lisa doing grocery shopping in 2 different stores. And then another 4 videos depicting another central person, Tom, in the same set of 4 situations that Lisa was in. So here, the 8 videos is in fact a systematic combination of 2 persons and 4 places, which the 4 places can be subdivided into 2 schemas, cafes and stores. After viewing the 8 videos, they had the participants to recall and then verbally describe the contents of each video. And the whole time they were doing the fMRI scan. So to understand the brain activity during video viewing and recall, they perform analysis on the fMRI data they collected. So before beginning the analysis, based on existing research, they identified regions of interest in the brain. So these regions are anterior temporal network, posterior medial network, medial prefrontal cortex, and finally para-hippocampal cortex, which is basically, we can say it's hippocampus. And then after they identify the regions of interest, they perform representational similarity analysis on them. Specifically, using this analysis, they want to know whether a particular region of interest would elicit similar activity pattern for videos showing the same type of content. For example, if for a region of interest, it shows similar activity for videos showing the same person, then we can say that this network most likely encodes information about persons. And same for schema and then places. On the other hand, if they found that all regions of interest elicit very different activity for each video, that means the DMN network together kind of integratively encode each event in a unique way, but there's no sub-network pulling apart different elements kind of shenanigan there. So with this analysis, they found that overall, they had evidence for subnetworks in the DMN processing elements of an event during encoding and recall. Specifically, they found that the posterior medial network elicits similar patterns for videos showing the same context or places. So if basically they have the similar pattern when the video show the same cafe, regardless of whether it's Lisa or Tommy in there. And secondly, they found anterior temporal network shows similar pattern for the same person. So same activity for the 4 videos that Lisa is in or Tommy is in. And then the medial prefrontal cortex shows similar activity for the same schema. So they have similar activity pattern among the 2 cafes and then among the 2 stores. Finally, they found that hippocampus show unique activity patterns across the 8 videos. And in addition, they found that this pattern similarity in hippocampus will be higher between experience and recall if participants could record more details about the video. Basically, if the content of recall aligns better with the video, then the activity in hippocampus between the experience of the video and the recall of it will also be higher. And these 2 results combined together shows that hippocampus is the hub that combines the element processed by other subnetworks for recombination and then reuse during experience and recall. So in conclusion, this paper found that subnetworks of DMN pulls apart the different types of contents in everyday events so that this information can be flexibly reused and recombined across different people, places, and situations. That's it.
Yeah.
Okay.
Thank you, Kenshin. Yeah, so actually I had one question. You seems addressed that, so I just want to check that. So in the second question, they addressed the hippocampus correlation in hippocampus between recording versus encoding. They use the mismatched event versus matched event. So you explain that, they compare or they class events into two groups. Again, one is match and the other is mismatch. And that's according, they, group according to the performance of recall in a sense. So better recall versus, or whether participant could recall the detail of the video better than the other with the same image, right? Okay. So first, the reason why I asked this question is that I could not understand what did they mean mismatched. So, in their paper, they said that, maybe the pattern reinstatement is related to recall success. So they use recall success, but this task does not have any success versus fail kind of threshold. So for me, it was not unclear to how did the study determine this event is success and the other is not success.
I caught the word verifiable in their text. So they, when they report, some details, then they will verify it against the video.
Mm-hmm.
Of course, this is, manual done by them, but I suppose there's not too much room of, decision bias when they verify them, because those are pretty simple videos and they can watch it for like many, many times.
So, okay, yeah. I just, skimmed through this part and I couldn't understand how they, classify in, event into two. So I just wanted to confirm that, how they did that. And yeah, I agree that, and I guess, they mentioned how they did that in the method and supplementary material. So I need to read that to understand how they did that. But yeah, anyway, so that, clarify my questions. Yeah, regarding, clarification question, I don't have any further. So maybe we can start discussion. Yeah, I think, in the summary, you didn't include the exploratory analysis part, right?
Yeah, I didn't.
So I guess it's better to mention that as well, because it's also interesting. But my comments question are related to that. So in the exploratory analysis, the study think that for each brain regions, this information processing will be, occurred in different time scale. So maybe some region, process the information earlier than the other or something like that. So they tried to investigate that as a part of exploratory analysis, and they found that, or what they said is that these regions or sort of networks seems to have different time scales, and that's what they conclude from the analysis. But my question is that how can we, further imply the mechanism of information processing, what's going on in the brain? Because, yeah, of course, this is exploratory, and also they mentioned something about the time evolution, the brain in the discussion. But I'm just curious, what is the, possible mechanism? Because, this result seems to be a little bit, difficult to interpret. Because, so when I look at the paper figure 8, my impression is that, the 3 regions, PM, AT, MPFC, these subnetworks seems to have similar time, or trends in a sense. So, like, you will
hippocampus.
Yeah. So that, obviously hippocampus seems to have, distinct time scale from the others. But, I don't know what does it mean. Or
pointing to this binding problem of video viewing. Yeah, what does it mean when the subnetworks processing the elements have the highest activity, or like highest, well, you can say it's highest activity at the middle of video viewing. It's perplexing.
Yeah. So I don't know. So in the discussion, they mentioned that, hippocampus, and I remember that, I read something similar, but in other studies. But what they said, or what the discussion says, is that the hippocampus activity in the hippocampus seems to be stronger at the event boundary.
Which is consistent with what they found here.
Yeah. Yeah, that's consistent. But again, the question is, what does it mean?
Yeah, I was imagining when I read this result, I was imagining hippocampus is like, oh, there's an event happening, at the onset, so they're like really excited, and then
Okay.
and then at the offset, it's like, oh, it's finished, and then it's also very excited. And also they kind of finish the integration at the offset or something like that. So they are like, oh, let's store this for later reuse.
I see. So this, activity hippocampus is kind of switcher for record or remembering the pattern or something. Like, okay, now let's start, remembering the pattern, neural pattern. Then, at the stimulus offset, then, okay, it's finished.
Yeah, it's finished. And also, you see how the other networks that process the actual elements of the event, they are the most activated in the middle of the event, right? So that's the time when these networks are working. And maybe towards the end of the event, they are like, oh, I'm done with my job here. Let's send these information to hippocampus, and hippocampus at the offset, they're like, yeah, let's get to work.
I see. Yeah, that makes sense.
This is entirely my imagination.
Yeah. So, yeah, that makes sense. Maybe they mentioned something similar in discussion, but again, I could not, or I just didn't have enough time to, read the discussion in detail. So I'm just curious, how we can interpret the last exploratory analysis results.
I guess to understand this, you need to maybe follow-up studies with functional connectivity analysis would be very useful. So during onset, middle, and offset, what's the connectivity pattern across these networks are like? Then we might take a glimpse into what they are actually doing and why do we have this time scale?
I see. Yeah. Of course, this is a part of, exploratory and the study. In the paper, they mentioned that, what we can imply from the results regarding time evolution is limited. So further, investigation is required to, think about what's going on in that times. But yeah, anyway, that's what I wanted to, ask discussing about this paper. And I don't think I have any other, question, comments. Because, the results and the approach was clear. The first part is really clear, so.
Actually, I have a question, actually, not clarification question. So the current study looks at pretty basic semantic elements of an event, right? So like places, people, this kind of thing. But we can easily imagine there are other frequently show up elements in an event that is not measured here, such as emotions. So are they represented in the DMN as well and integrated by the hippocampus when they appear? Or they require some kind of other regions outside of the network, and then they need a connectivity between those regions with this network and then integrated by hippocampus.
I see. Yeah, so as you described in the summary, the video they used is just, someone shopping, someone, drinking coffee in the cafe. It's not like a, emotion, induced videos, but if it's more like, funny movies, for example, then, it's easy to, manipulate participant emotion, and then maybe we can apply the similar analysis to these data set and see whether we can see similar, pattern in different brain regions or maybe in default mode network. I'm not, familiar with default mode network and emotion. So maybe other regions, maybe.
Yeah, I can imagine maybe they need some kind of regions outside of the network, because DMN, with my limited knowledge about DMN, it's mostly activated when your brain is idle, or you are idle and you are not performing any cognitive task. So given these videos where you're just looking at people doing stuff, that actually fits with how when you're idle and then the events happening around you. And you can see it makes sense why in this study DMN networks give a very good explanation to video recall and experience. But like you said before, if we involve videos that is more engaging in a sense, or emotionally engaging to be more specific, then it might require more than DMN.
I see. But yeah, about the difficulty of this task, I'm not sure whether the brain is idle during the task, because at least as a participant, you need to, or you will be instructed to, this video will be recorded in the next session. if you have that kind of instruction, then, or at least to me, it was like, okay, I need to watch this
You
video
remember.
carefully. Yeah.
True.
Yeah, and during recall stage, my feeling is that, okay, what was in the what was there in the video, so I need to think a little bit about, and that's not idle at all. So brain seems to doing some tasks. So yeah.
And also, I guess another thing we can take into consideration is that this paper sets up in a way that it tries to explain everyday events that we experience. But in the context of this study, the we experience part is relatively weakened because we don't engage with the event. We are basically observing other people going on with their everyday events. I imagine if they use some kind of mobile neural imaging devices and then actually have the participant to go into like that designated cafe or something, then it will be very interesting to see what kind of brain activity pattern is there.
I see. And other possible approaches to use VR headset, and then virtually explore in the groceries, or yeah, you can't drink coffee in cafe within VR headset.
That also introduced noises because like once you drink coffee, like the taste of coffee, expectation about how the coffee tastes is going to like, and
yeah, but that maybe is a kind of important cue for or
exactly.
at least that information is strongly linked to the scene or context, right?
Oh yeah, true. Like you walk into a cafe, you expect to smell coffee,
Yeah, exactly.
something like that, and that would be a very important information of events. And also, they in their intro they mentioned something about cross-modality coding of events or something like that. Of course, in this study, they were not able to do this because it's. I don't remember the video, whether the video was soundless or not, but it's mostly visual.
Yeah. So now I feel like, maybe it's possible to, put some coffee in front of the participants while, viewing this cafe context or cafe videos, and whether we will see, but yeah, of course we will see some differences because of the, coffee aroma, but yeah, we may, or we should be able to something interesting by combining these, visual information and, olfactory information.
Yeah. So I recently read a paper about mobile neuroimaging devices. Apparently, they have been developed to be reasonably well, like record the neuroimaging data with good enough precision while not getting too much movement artifacts. So you can totally have people to wear this kind of mobile EEG caps and then just like go into a cafe. Although it's a little bit weird, you walk into a cafe wearing those caps. But yeah. And in that paper, they also talk about how real experience, such as real social interactions, compared to like looking at watching videos of other people's social interactions, these two elicit pretty different brain activities. So your kind of own participation in it seems to be very important.
I see. I see. Yeah, but one difficulty is that you said that EEG, right?
Yeah.
If EEG, then we can't do or at least investigate what's going on in hippocampus, right?
Yeah, you can't have the fMRI machine just like,
Yeah.
yeah, too bad.
Yeah. Mm.
Oh yeah, DMN probably you can't really record the DMN with EEG, right? Because DMN is pretty much inside, like medial area.
Yeah, so I don't think we can do something similar in EEG.
Oh, they also have mobile intracranial recording device as well. So you can recruit people who are already going to do like the open brain surgery or like they finish doing it and then just do the intracranial recording. But yeah, that's very expensive.
Yeah. But yeah. Okay. So yeah, I don't have any other questions, comment.
Yeah,
Do
I
you?
don't have any other.
Okay, so shall we wrap up here?
Yep.
Okay, then see you next week. Bye bye.
Yeah. Bye bye.